Relational algebra. In our previous chapters, we have seen RDBMS, Relational Database Management System. That is the concept of creating a table and feeding the data inside a table. Now talking about relational algebra, it is a procedural query language that works on relational model. The purpose of a query language is to retrieve data from database or perform various operations such as insert, update, delete on the data. Now when we say that relational algebra is a procedural query language, it means that it tells what data to be retrieved and how to be it tells us how the data is to be retrieved and what type of data needs to be retrieved. Now on the other hand, relational calculus is a non-procedural query, which means that it tells what type of data to be retrieved but does not tell how to retrieve it. Now in our next chapter we are going to work with relational calculus. Now in this we have different types of operations in relational algebra. These are the basic operations and derived operations. Now the basic fundamental operations which we have select, project, union, set difference, Cartesian product and rename. So everything has a unique identification, just like you can see that the sigma, pi, union, set difference, minus, cross, p has a unique symbol which is used for these operations. Similarwise, when we are working with derived operations, we have natural join, left right full join, intersection, division. So every part has a unique symbol. Now in our further chapters, let us start with the select operator, which you can see the symbol. The select operator is denoted by sigma and it is used to find the tuples or rows in a relation which satisfies the given condition. Now if one has to understand what is it about, so when we talk about the where clause in SQL, which is used for the same purpose. Now the syntax of select operator or sigma, then we have the condition. Now let us have a look to this. When we talk about the select operator, we have a table. Now this refers to, we can say that select customer city, Agra, customer. Now this is referring to select customer city, where customer city is equal to Agra from table customer. This is how we also have simple query language for this. Select customer city equals to Agra. Select star from customer. Customer refers to the name of the table. So this is how it is going to refer. This is going to refer select all the customer city which is equal to Agra. Now you can see that this part and this part has the customer city as Agra. So this is going to display these two values. This is what is select operator or sigma operator refers to. Now when we talk about the project operator denoted by pi symbol, it is used to select desired columns or attributes from a table. Now project operator in relational algebra is similar to select statement in SQL. Now let us see the syntax of this. This is going to specify select column 1, column 2, column 3 from table name. Now this is what we have. In this example we have table customer with 3 columns. We want to fetch only 2 columns of the table, which we can do with the help of project operator. Now we can see that how we write this, how we are going to write this. This is going to refer select customer name, customer city from table customer. Now this refers to, it is going to select the column customer name, customer city from the table customer. This is what it has done from the above table. You can see that it has selected the name of column customer name, customer city from the table customer. Now let us have a look to the union operator. Union operator is denoted by U symbol and it is used to select all the rows tuples from two tables. Now let us discuss union operator a bit more. When we say that we have two relations R1 and R2, both have the same column, and we want to select all the tuples from these relations, then we can apply the union operator to these relations. Note that the rows that are present in both the tables will only appear once in the union set. In short, you can say that there are no duplicate presents after the union operation. Now let us say that this is table 1 union table 2. So this section is going to display all the columns of table 1 and table 2 and will not repeat the column. Now this is the table course. Another table we have student. Now when we are going to take the union of this. Now let us have a look to the query. Select student name from table course, then student name from student. So this is going to display the column name, student name, and from the table course and from the table student, and going to display all the data from that column. Now you can see that 1, 2, 3, 4, 5, 6. You can see that in this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. In this all the repeated data in both the columns have been removed. Now we can see that there are no duplicate names present in the output, even though we had few common names in both the tables. Also in the course table we had the duplicate name itself. We can, in other words, we can say that it is the combination. Now the next part comes about the intersection operator. The intersection operator is denoted by this given symbol. It is used to select the common columns from two tables. Now let us take example of two relations R1 and R2. Both have same columns and we want to select all those tuples or rows that are present in both the columns. Now then in that case we can apply intersection operators on those relations. Now when we are going to apply the intersection, so this is going to display, you can see that we have two tables, table 1, table 2. Then when we run the query, it is going to display the common names Aditya, Steve, Paul and Lucky. Aditya, Steve, Paul, Lucky. Aditya, Steve, Paul, Lucky, and any other names that are not common have been discarded. Now, let us talk about the difference. The difference is denoted by minus, a simple negative. Set difference is denoted by minus symbol or dash symbol. Let us say that we have two relations R1 and R2 and we want to select all those tuples and rows that are present in relation R1 but not present in relation R2. So this can be done using set difference R1 minus R2. So we can say table 1 minus table 2. So when we run the query, we have a projection operation in this. Student 1, select student name from table student, then select student name minus from table course, and it will only display which are not common and have a unique value in student name. Now all the common names in those tables will be omitted and those names, the left out names that are only in student name will be displayed. Now when we are talking about the Cartesian product, in Cartesian product is denoted by cross, and let us say that we have two relations R1 and R2 and then the Cartesian product of these two relations would combine each tuple of the first relation with the each tuple of the second relation. Now let us have a look to the example. In this we have R1 and R2. Then we have table, column A, column B. Then we have second table, second relation, second column. Now when we find the product of R and R2, you can see that we have column A, column B, X and Y. The number of rows in the output will always be the cross product of number of rows in each table. In our example, table 1 has 3 rows, table 2 has 3 rows. So the output will be 9 rows. Now you can see that how we are going to do that. Column A, AA, AA. Then it is going to display AA 100, 1, 2, 3. 1, 2, 3. This part. So every section is going to have a 3 part. That is the cross product. Now talking about the rename operation can be used to rename a relation or an attribute of a relation. Now let us directly take an example. Let us say that we have a table customer and we are fetching customer names and we are renaming the resulted relation to cust underscore names. So in this we have used the query. And this is going to be displayed as cust underscore names. So this is all about the relational algebra and as simple as it looks. As simple as the SQL sequential query language, we are also going to work with sequential query language in our forthcoming chapters. In our next chapters, we are going to work with relational calculus and keys.